Okay, so we are going to start with a little bit of module 1, especially focusing on things that can come. So I'm going to skip this part. So this part is the one that you should know for the sake of understanding the concepts. Okay. But actually, once you come to the part when you realize that carbon needs to have 4 bonds, that's the part where your actual part of the biochemistry kind of starts. So yes, you should know what is isotopes and what are elements and molecules and compounds, and you can have like quiz questions from there. But as you can imagine that, the main concept kind of starts a little bit later. So I'm going to go over there. So not saying you skip something, but then yes, of course you should know the difference between organic and inorganic compounds, and especially their properties, which is not really that difficult, because if you know the examples, like methane is a kind of gas, you kind of know that it has a low melting point and a low boiling point, right? So whereas salt does not. So those are the things that you already know, but please review the table, and both the slides have information in 2 different ways. Okay, so now representing organic compounds, here is where some of the confusion begins, where because different people just write in different ways. And for me, it's really important for you to show all the different ways, because once you encounter something in your field, most of you being in allied health, I just want to make sure that you feel kind of comfortable with what you see. Okay, so I am going to go to skip this unless you want me to stop and explain something, which I'm happy to explain. But otherwise, I'm skipping this and kind of coming here. So you do know that carbon needs 4 electrons to complete its shells. So that's what we talked about here, that carbon needs 4. And so CH4 is the simplest explanation of carbon having 4 bonds, one with each hydrogen, in order to complete its valence shell. And hydrogen, on the other hand, needs only 1 electron, which is also, it shares, one hydrogen shares one of the electrons with the carbon, and so on and so forth. So we have talked about this. Okay. Now about the kind of questions. So I would highly recommend that you get familiar with this table. So I think one of the problems that I notice is like, which sometimes is a little bit of, I guess, which creates a problem, is what people may not remember that C2 is, the prefix is ethane. Okay. So you have to remember that when there is 1C, when there is 2C, where there are different C's will indicate different starting names. So like ethanol or ethanoic acid or ethanol is all 2 carbons. So that's something that I hope that you will remember. Similarly for 3C and 4C. And I always think that after 4 is a tad bit easier, but if you don't, no problem. You should try to at least, try to have this part taken care of, because you rarely get asked like, what is a C14? Like you might have seen in the assignment, I've never asked you what is C14 or C16, but we have had a couple of chances where we have talked about methane, ethane, propane, butane, and related hydrocarbons. About the suffix. Suffix is the, basically, actually, this is not prefix and suffix. This is 2 words making up 1 word. So ethanol or ethanoic acid or ethanamine or ethanol represent all 2 carbon and 3 carbon, and so on and so forth. So a question, what kind of question can come? A question can be like, I show you something like this, right? Like I show you this and say, what is this? I'm just giving you an example. It's not like it's on the exam. So if you can at least say it's, what is 2 carbon, if you're not like too off, if you don't say like this is pentane, like that would be nice. Like I want you to be at least be able to say this is 2 carbon, so I know this is ethane, and with double bond that's an alkene, so it's ethene. Simple stuff like that. Same things with the functional group. So if you go there to the functional group area, like, I mean, similarly, if we go over here and I show you this, like, I feel like, what do you guys think? Like, if I show you this, would you be able to name it? That's my question to you. Like, for example.
Yes.
Okay. Yeah. So that kind of thing, that is exactly what we are looking for here. We are looking for just your basic understanding of how the nomenclature works. Okay. So that's what is very, very important as a first step, that are you able to understand how this works? This is valid for your entire course. So by doing this exam, I'm ensuring you're on the right track. If you're not, I'm going to help you. Okay. Similarly for aldehyde. So as long as you know the group. So remember between aldehyde and ketone, and someone asked me a really good question today, and that is, sometimes I get confused between aldehydes and ketones. So yes, you have to remember that aldehyde comes in the end, ketone comes in the middle. So always that distinguishing leads to a different compound, right? So aldehydes have a C double bond O group, but they have actually a CHO, okay? And ketone, on the other hand, is just in the middle. It's a C double bond O group, and there is no H attached. So things like that, for us to remember. So please learn about your all of these functional groups. And if you have any questions about this, you can ask me now. Do you have any questions that you want to, I guess, share with me now? Or maybe share anything that confuses you. Like, this is what is confusing in this. Okay, so far so good. I got asked another really nice question. So thank you for sending, yeah, all these questions. Like, for example, someone said, like, if given a compound, like it is C something, it has some numbers like C5H something N something. How do I know if it is amine or amide, right? So if you see here that that amine group is like NH2 and that one is CONH2, okay? So, things like that, that will help you. Also do all of these exercise that might help you, just naming them. I know these were just, out there, but they are all like very easy to name. For example, this would be a propanol, and this would be ethanamine, and so on and so forth. So just having that practice, you can get lots of additional practice. There are resource books. There are 4 books in there, and I'm not sure, I think one of them has a link that sometimes, like, for some people it feels like it's broken, but the rest 3 books, Leninger, very useful, guys. There are some awesome books in there. You can go ahead and practice more, and also ask for help if you ever need to ask me. Okay. So about this, I would expect you to know at least, what this is, because this is something that we actually did in the next chapter, right? So would expect you to at least know about optical isomers and geometric isomers. We have done these. Maybe we haven't done the structural isomers so much, but at least we have done the geometric, which did the trans and cis difference, and the optical, which is actually, they look like mirror images, but they're non-superimposable. So with this, I want to stop sharing module 1, because we're just doing a very quick review, and we are right in the middle of between 2:30 and 3. But if you have any questions, you can let me know. And I want to go to now module 2. So give me just one moment. Just need to pull it up. So again, the goal of the exam is just to make sure that you are learning the concepts right. It's not, according to me, it doesn't contain any trick questions. It is pretty straightforward. If you have done the assignments, you should be just fine. Okay, so about module 2, and since the assignment 2 is due tonight at 11:59, so if there is anything you want to ask pertaining to the assignment, you can stop me. So in module 2, what is most important is, first of all, that you know that how are carbohydrates represented, that you always end them with OSE, and they can be having an aldehyde or a ketone group. So these are some of the things. Of course, there is the structural part there, that aldos have the group in the end, and ketos have group in the middle. It is a polyhydroxy, which means that poly is many and hydroxy is these groups. And for most of them, it is, some of these can be looking very similar, but they are having some differences. So in order to explore that, first of all, we need to know the numbering system, like, 3 is triose and 4 is tetros and 5 is pentose. So this just makes it easy if you especially know the geometric shapes, makes it really easy. However, when you are actually calling them, you're going to call them by the common names or the popular names, like glucose, mannose, galactose, and fructose, which of course there, you can't really tell a glucose is a hexose or not. But now with your common knowledge and with seeing the structure again and again and again, you probably do know that a 6-carbon sugar, glucose is a 6-carbon sugar, right? So that's one part of it. And many of these, most of them are aldehyde, having an aldehyde functional group. Only some have ketone. And I kind of remember, like, think about fructose and think, okay, the fruity sugar, that's the one that's having ketone group. Okay, I want to state something here, that there was a confusion in the assignment. In the assignment, I think I have not used the same name. And even though I corrected the assignment, a lot of people had already downloaded the assignment. The spelling is not the same, but it is Fisher and Howard. So I am going to, first, I wanted to say it to you directly, and then I'm going to put it out in the announcement that there is a correction, that the long chain structure is called Fisher and the ring structure is called Howard projection. So that is something that, again, is extremely important, because you will see most of the time monosaccharides being represented in the Howard or a ring-like projection. It's also called a ring structure. So it's really, really important to know that. Also important to know that these carbons, they don't disappear. They are all over here. Okay. Any questions from this particular slide or anything before this? Okay. Okay, all right. So just going back to here, we have learned some important concepts here. Our first important concept is the concept of anomeric carbon, which is the carbon that is attached to 2 oxygen, and the way it is attached. If it is diametrically opposite, we are going to use the term alpha. And if it is together or on the same side, we call it beta. And you have to know what is alpha and beta. So again, what kind of questions can come in an oral exam or in an exam? Just show you the structure and say, is this alpha or beta? What kind of sugar is this? So just simple things like this, where I'm just conceptually testing that, are you able to understand the fundamentals? That's it. Okay. So if you see here, it's not very hard to distinguish, and you have to also be able to find out the anomeric carbon. It's very tempting to say that the C that is visible is the anomeric carbon, because you can't see any other C's. Remind yourself that 1, 2, 3, 4, 5, all, and 6, these are all C's. Okay. Also very interesting, the assignment question, you have to make sure that you're counting all the C's and H, because some people did make a mistake in here. So I request you to go back to your assignment and see if everything was right, and if something was not correct, then I would say that you should ask me if you can't find the answer. We talked about this for a while, even though conceptually, it's really nice to have this hand figure and learn about what are the L or the the levo and the D, the dextrose form. These are the 2 different forms. But however, we are not going to use this concept and try to visualize molecule. That will be making it really, really hard. So anyone who is doing the assignment, I want you to listen to these 2 slides very, very carefully. Okay. The distinguishing between chiral and achiral. Look at this. This slide is your key to understanding the chirality concept. A carbon that is bound to 4 different groups is an asymmetric carbon. An asymmetric carbon is chiral. Okay. So again, I'm going to repeat this. If it has, like, in place of R1, let us say it has H. In place of R2, let us say it has a chlorine or chloride. In place of R3, let us say it has an OH, hypothetically. And R4, it has, let us say, CH3. 4 different groups. When 4 different groups are attached, we automatically declare that this particular carbon is chiral. Okay. And what is the reason for that? The reason for that is because if you see this carefully, there are projections and R4 is going inside the plane of the paper. So you can imagine it's coming to the, going to the behind of the laptop screen, and R3 is coming out of the laptop, and R1 and R2 are right sitting on the laptop. So they're no way gonna match. So if you have not done the assignment, please remember that chirality means every carbon that is attached to 4 different groups is chiral. What about if they're not 4 different groups? Answer is it's not chiral. Simple. Okay. So that again is a kind of question that can be asked during an exam. This is whether I ask you in written or oral, questions are not going to change. Okay. We talked about this a little bit, and you can see how these are 4 different functional groups. So the idea is not to go over it again, over the content again, but just to remind you that these is L&D forms, and L&D forms are called enantiomers. So if I show you 2 structures and say these are these enantiomers, don't panic, just take a look and see if they have, if you think there is a, they have a format like that, because where they have all 4 different, they're going to be enantiomers. They're, and you know, they have this, they have switched the sites, L&D forms with 4 different things, and you know, they have their OH group switched, they are going to be enantiomers. So just something like that. And sometimes,
Can I ask you a question?
yes, my dear.
I think people will have the same question that I do. I remember last time we say for chiral, it had to be 4 difference, right? What
Yes.
about it is up to 4?
Up to 4 or after 4?
Like about 4, like if you have 5.
5, yeah, it's, you know, carbon cannot form 5 bonds. That's the main thing.
Because I feel like on the homework, I don't know, maybe because I'm thinking like when you connect them, there is a C. So will that still not counting as a 1 extra? Because
Great question. Okay, I understand what your question is. Okay, so let's take a look at this one. You know, I'm just going to just say it real briefly. So for example, this carbon, what are the groups attached? So one group is this, one group is this, one group is this, and the other group, you know, what is that? That whole thing is the group. You know, that whole of it, that whole part with the C and a CHO and OH and H, that entire thing is attached to the C, making it asymmetric. So what becomes the confusion is when you see that skeletal structure in which there is an extended chain and you feel like, is it or is it not? Then please fill it up with C's and H, and that will make your understanding clearer. Okay. Valerie, did I answer your question? Valerie? Okay, I'll give her some time then.
Yes.
Okay. Yeah, so I was saying, did I answer your question correctly? Like I'm saying, when you see this kind of thing, you may feel like...
They look like they're repeats. So we don't count the repeats, we just count the single ones.
Yeah, we are just going to count this as, because we are just talking about this carbon. So we're going to be selfish and focus only on this carbon and see what are the 4 things it's connected to.
Okay.
And so this is actually connected to a very different thing than CH2OH.
Right. Thank you. That's very helpful. Thank you.
Yeah. You can, I mean,
I feel like sometimes I go more than 4, so I was wondering. Below 4, I know it's
easier,
right? But I feel like for child, I was thinking and I was counting 5 in some of them, so I wasn't sure.
Yeah, but you have to just focus on the central one. That's why it shows like it starts from a center and then it branches out. So to see what those branches are like, same or different. So, I mean, we're just going to focus, and if you have a confusion like this, like which carbon are you talking about, then you can always label those carbons and say, I know C1 is chiral and C2 is not. Like C1 is a asymmetric center and C2 is not. So you don't have to do that. I'm just saying that's a possibility. Also, what are diastereomers? You know, same functional formula, but arranged in a different way. So these are some of the things, again, that can be asked. So I know diastereomers can be confusing. So I'd be kind of careful asking these kind of questions because I already know. So my goal is to make sure that you're really, really understanding, is not to confuse you. So I stay away from things that will add to the confusion, I guess. Yeah, I don't want to spend too much time here, except for making sure that you know what is L and D forms. You know, the left is, and I think everyone did that right. That was amazing, guys. You know, having that identified that the last carbon, last asymmetric carbon, and having the OH on the left side is L and on the right side is D. And that can be a possible question. Is it D, L? What kind of molecule is this, right? So, like I said, very similar to the assignment. So this summary, I'm gonna just skip, and I really like this slide because it kind of sums it up, like, you know, how you have the D and L form. So there is alpha D, beta D, and then gluco or fructo for the common name, and furanose or pyranose for the furan, which is the 5 carbon or the 6 carbon ring. So not like it's, I like it, this means it's going to be in the exam. All I'm saying is it just gives you a complete picture of everything. About the reactions, and since it's almost 3 now, I don't want to spend more than 5 more minutes, is to say that, you know, one of the most important reactions here is of reducing and non-reducing, and it's done using Benedict's or Fellings, and we talked about Benedict, so I'm going to stick to Benedict's, where copper is reduced and you get a blue color. I mean, sorry, the red color, right? So the blue to red conversion happens only if the sugar is a reducing sugar. Okay, so in this we talked about also about how to make disaccharides and polysaccharides. It's important to know that there is something called glycosidic bond, and that's what this is all about, right? This one is, you know, the glycosidic bond is the one that connects two monomers. Similarly, also polymers. And I was pretty excited to see how you guys were able to, you know, show some of those dehydration and hydrolysis reactions. And I think a lot of people did a great job. And if for any reason you didn't get full points, you can always go back and do it. And I'm pretty sure that will help you in understanding. Same with the carbohydrates. It's the glycosidic bonds, just they're arranged differently. Now, do you need to know why these are different? Absolutely. You need to know that at least you need to know that starch is the storage element in plants and glycogen in animals. That's something so simple, something which you might already know from a prior biology 101 or 102 class. Similarly, cellulosis in plants and how they are different. So you can go over these things by yourself, and of course they're important, but you can go over these by yourself, like I said. And I want to stop sharing this, and then I want to go to module 3. Okay, it's a lot, I know. And I really appreciate your patience. You know, before I start this, I want to ask you if you have anything that you want to share about, anything that worries you, or tomorrow I have a little bit of time. So if you felt like you need some help tomorrow, specifically is a day that I could help you.
Tomorrow, do we have to make appointment, or it's just gonna be specific time like today?
It can be. We can decide it now. Is there I know it's a Monday, so not it being President's Day. Some people have an off and others don't. So I wanted to know if people are free in the morning and be interested in doing something or asking any questions. So I can be available for some time, let's say, I don't know, between 10 and 11 or something. Or 11 to 12. Well, let me know. You don't have to tell now, or you can think over it and let me know. But most important thing is please do not think that this being discussed 5 times in the class, so I should go over the video and not bother my teacher. Please do not think like that. It's very important for me that each one of you understands what you are doing. So I'll do my time management. Don't think about whether you are wasting time or not wasting my time. Let's just get this clear, okay? I have, for that reason, opened some additional slots tomorrow in the afternoon for oral exam. And I personally feel many of you are ready. So, I mean, I would say that you should just get it done with, why keep it hanging? I mean, since you know the concepts, if you got good points in assignment. Also, I want to warn you about the test. Like, what's going to happen is, like, I know you won't, but if your intent was to look back for every question, you will run out of time. I mean, if you feel you're ready, then you will be able to do much better in the exam, as opposed to thinking, I think I might have time to go back for every question, because that's where you lose time. I know that exam is very, very doable in 30 minutes, but I put 45 minutes for a reason that people want to take their time. But I feel like that's plenty of time. Okay, so with this, I want to begin module 3. I try to make it as, I guess, as good as possible, but I know that it's a lot to take. So we'll try to do as best as we can, and then we put over some things for the next week, because next week is oral exams. Okay, so in this particular module, you are going to learn about lipids. Now, as you know, lipids are kind of tricky because for the reason that they don't have a structured format like carbohydrates, like a monosaccharide and then disaccharide and polysaccharide. They don't have that kind of formats because it's a mixture of different kinds of different things. Okay. So we are going to learn about what those different classes are and what is the function of those classes, because that's where we come to your fields, right? Also, what is some part of their biochemistry or the biochemical functions and features. So I'm going to skip this one and go to what lipids are actually. And please, you can read it. It's something you can easily comprehend. And if you want to understand more, I found this really nice review, which I thought I would share with you. So lipids, they are not like proteins or carbohydrates. They are very diverse and they have a common characteristic, and that is like anything that is not soluble in water. So, okay, so anything that's not soluble in water is clubbed pretty much as a single grouped under a single category called lipids, and they are non-polar. So, when I was in college and people would say polar and non-polar, sometimes it would sound so confusing. So I thought, okay, let's start with addressing that. What is polar and what is non-polar? I thought it would be a good start. So polar is unequal distribution of charge. So we're just going to tackle the left side first, then we come to the right side. It's kind of asymmetric molecules and they are soluble in water. So let's see, what does it mean? So hydrogen chloride has, it's a little bit asymmetric. This is more positive and this is more negative. Similarly, ammonia, you can see that, these are positive and this is negative. And if you say, methyl chloride, then chloromethane, whichever. So this one also has it also does have a chloride group, which makes it negative, and these are, make the charge differential. So as a result of which, these are soluble in water. What do we mean by asymmetric? So if you look here, these are asymmetric things, it helps us identify. However, let's go here on the right-hand side. And now let's start with the figure on the bottom. So symmetric, okay? Well, I see why it's symmetric. The apple, not the company, like the regular apple, and this person with the haircut, which is symmetric. So I get it, I guess, that if everything is same, then it's not going to be like unequal distribution. It's going to be equal. And that's what makes it non-interactive with water. And that's a non-polar compound. So that's the first thing that we focus on here. And it's important for understanding that we are going to be dealing with this right-hand side throughout this particular module. So how do we define lipids? Okay, so lipids are what we call esters. So if you remember, esters is a term that we learned in module 1. That's why module 1 is so important, right? And so they're esters and amides of fatty acids, but not 100% of the time. So again, there's something that's existing in nature. So if it gets confusing, remind yourself you're learning what's already there. It's not something that's been created, right? And we are going to need a couple of readings to understand this. So we're getting a head start right now. So there are different ways of representing lipids, and we're going to see that on the right-hand side. So if you focus on the right side, there is a structural formula, there is a space filling model, and there is generic simplified depiction. Okay. So what is a structural formula? Structural formula is the one that's having all the carbons and hydrogens and nitrogens and anything that we have, anything and everything that we have learned so far, right? Shown here is a fatty acid, and shown here on the right side is a phospholipid because it has a phospho group, so it's a phospholipid. Also on the space filling model, there is the same thing being shown here. It looks a little bit different, but you can appreciate that the orange, like not the orange, I'm sorry, the red part is right here. The cyan is right here, cyan or blue, whatever you call that. And the phospholipid looks a little different. However, what is the role of these? So if you see here, the role of this is on the right side. And if you see here, you must have read 1,000,000 times lipid bilayer. And that's what the membranes are composed of. And that's where the importance of phospholipid is. Okay. So we're going to learn a little more about that, but I mean, that's where the functionality of this comes in. And fatty acid, like just showing here, structure of a micelle. So all of these are extremely important, and we're going to learn more as we go. Just focusing on this, they have a polar head in here, okay, and non-polar tails. Polar means they like water, and non-polar means they don't like water. So there comes the term hydrophilic or water loving, and hydrophobic or hating the water. Okay. So phobia to the water. So this part, it seals the cells because it is just, it's hydrophobic, right? So that's, also the hallmark of fatty acids. So just showing to you and introducing the terms hydrophilic and hydrophobic, which you might already be aware of. Any questions so far about lipids? Okay. Okay, so let's see. So classification. There are different ways of classifying. I am going to share with you what, in my opinion, works best for you. Okay, because there are different ways based on chemical formula. There is one way to, like, there are esters, triesters of glycerol, derivatives of sphingosine, steroids, econocides. So you can do it that way, or you could do it based on function. Oh, looks like there is a error in here. Okay, so there is storage, structural, and signals. So what we are going to do is we are going to do it based on the function, because function gives more logically a lot more sense. What are the lipids used for storage? What are the lipids used for structure? What are the lipids that are used for signaling and cofactors and pigments and all of that? Okay, so we're going to start with storage lipids. And also it's easy to correlate, storage lipids. Yes, we know that fats are stored. So we know that is something that we can kind of understand and keep in mind. So we're going to start with definition of fatty acids. Fatty acids are carboxylic acids. So now you do see how module 1 gets back in here. Carboxylic acids, which is R, where R can be any number of carbons, with a COOH group, which stands for the carboxylic acid group. Now, what can R be? It can be very few carbons or many, many carbons. They are long hydrocarbon chains, and they are mostly even numbered chains, okay, even numbered. So if you see here, this particular molecule there are 18 carbons in here, including the carboxylic acid. So 18 carbons in here, which makes this particular fatty acid. Okay, just as an example. And that this, whenever there is this long carbon chain, that's not going to interact with water. And that's one of the reasons why it is non-polar, right? So, and the function is storage. Now comes the interesting part. And this is the part that you can really, really easily correlate with the food that you eat. Okay? Saturated fatty acids or single bonds, unsaturated or having one double bond, and polyunsaturated, that is more than one double bond. So unsaturated and polyunsaturated, let's kind of keep that in mind. So saturated fatty acid. This is also very important for your assignment point of view, because you may be given something and say, is this saturated or unsaturated? So again, just kind of giving you that perspective from your questions point of view. This has no double bonds. No double bond means it is cannot have any more, it cannot accept any more hydrogens, this stearic acid. And this is a saturated fatty acid. Also for you to remember that saturated kind of gives me a feeling of like happy, like saturated, like, okay, good. So that's why I kind of remember like saturated is the one that doesn't take anything. Unsaturated actually can have a double bond. That double bond can change, that one double bond can change the entire structure, even though they are the exact same things, or like, you know, except for two hydrogens missing, but their properties are quite different. So look at this. A saturated fatty acid would look like this. Okay. Saturated fats immediately should remind you of butters or clarified butter, things that remain so solid even at the room temperature, because they are very tightly packed. They're like tightly packed. There is no space. They are even solid even at room temperature. However, if you talk about the unsaturated fatty acids, sorry, unsaturated fatty acids have these structured, that double bonds, which lead them to have funny kinks. These kinks are going to make them not having a very strong, like a regular structure, which means that these are liquid. And so you can think of oils and all of the things that can remain kind of, you know, at room temperature. They are not packed well, so they are liquid. So that's why it says here, think of the fats you use in the kitchen. Are they saturated or unsaturated? So sure, you're using some kind of oil, some butter, some fats, and you can think about those. Okay, so any questions among this when we talk about saturated or unsaturated? And I think I didn't say polyunsaturated is many double bonds. Okay. So all fats are not, doesn't have to be bad. And I know there are some terms in here like trans and PUFA and MUFA. And so we're going to go over that. Okay. So if you think of saturated fatty acid, double bonds, no double bonds. One double bond, mono unsaturated fatty acid. Wait a minute. That means it is, you know, MUFA, mono unsaturated fatty acid. What happens if it has many? It becomes polyunsaturated fatty acid. So multiple double bonds leads to that. Okay. Okay, so if you see here, we have come to a very important slide. Okay. So I would be very happy if you interrupt me if you don't understand this. We are going to learn how to name this. Okay. It's very simple. Just you have to focus once and you will see how easy this is. So we are looking here. We have a 18 carbon chain. Now you may say, how do you know this is 18 carbon? Okay, so I'm going to count this for you. Okay, so we have to count this carbon. Okay, just because it's attached to the acid doesn't mean anything. 1, 2, 3, 4, 5, 6. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Great. So it's 18. So I wrote the 18 first. Then I put this colon and I put 1, which symbolizes that there is only one double bond. But some of you who are working with me are like, where is the double bond? I don't know where the double bond is. So I say, okay, I'm going to tell you the position. The position is delta and then number 9. What is number 9? Carbon number 9. So 18:1, delta 9 indicates the position of double bond at carbon number 9. And, you know, this is, if you see here, let me try to, so if you see here, this is, you know, on the same side, like it comes back and folds on the same side. So it is cis, okay? And the position is 9, so cis 9 octadecanoic acid. I want to help you not worry about this by saying, I'm never going to ask you, what is this complete name? I might ask you, can you find out this first part? So let me label it with green. I might ask you, what is this? But I won't ask you, is this an octadecanoic acid or is it to find out that last name? Just because I don't think that's what you need to learn. I think what you need to learn is this part. Yes, you do need to learn this. Octa is 8, decanoic is 10, so that is 18. And yes, we get that point, but having understood this is way more important than memorizing this. So that's the goal, is not memorization. And also knowing that it's a 2-credit course, there is only so much that we want to learn. Looking on the right side, 18 is the number of carbons, 1 is the double bond, and this is the double bond location. Does anyone have anything to ask from this particular slide?
Yes, Professor. Do we not count the double bond at carbon 1?
No, good question. No, we don't, because it's COOH. You have already taken into account an oic acid.
Thank you.
Great question, because you know these are the kind of questions that can easily confuse people when they're learning it for the first time. So thank you for asking that. So things can get sometimes a little complicated, and we will get back to that, but I'm just saying how they can get a little complicated, but actually not too much complicated. If you see here, what we're going to learn here is that it is pretty much the same. 20, number of carbons is 20, is 2, which means the colon 5. Why? Because there are 5 double bonds. Let's count. 1, 2, 3, 4, 5. So there are 5 double bonds. Okay. What are the position of those double bonds? Well, you may say, I think it's a little confusing because the double bond is between this and that carbon. No, you just, I know that can be a point of concern, but you're going to just count the first carbon that kind of comes along here. Okay? So just the beginning carbon, not the ending ever. So that means it's at carbon 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So it is 5, 8, 11, 14, 17. This is the position. And it is eicosapentaenoic acid. Again, like I said, I'm not too worried about the eicosapentaenoic acid. I am more like, are you understanding this nomenclature or not? I'm going to come to this part. Are you understanding this nomenclature? I hope you are. If not, ask me questions. So yeah.
So you're saying that the positioning is start at 5 and end at 17? Is that what you're saying?
For double bonds. Double bond is at 5. Double bond starts at 8, at 11, at 14, and 17.
Okay, so that is the positioning for double bonds. Okay.
That's right. Yeah.
And then what is that triangle again? What is it? What does that
delta?
stand?
You mean the delta?
Yes.
That's just to indicate the position of double bonds.
Okay. Okay.
Because when you say 5, then you might say, like, if I say these, it has 5 double bonds, you can draw it. And you'll be like, where are the double bonds? I don't even know the positions. How am I going to draw this?
Oh, okay.
So between you and another person, or me and another person, I'll be like, we want to make sure that we convey that everyone knows that it is at these positions. And so we both are using the same compound. Let us say we both are using it for a reaction or for a medication. We need to like, we're doing the exact same thing, right? Now, okay, I did not invent this, but I know this can be confusing, but it will not be eventually once you understand. Have you heard about omega-3 and omega-6 and omega-3 fatty acids? Have you heard that name like in the market, or like people use it? Omega-3 fatty acids or
Yeah.
supplements, yeah. So what happens is that there is another way of counting this. And like I said, I didn't invent this. So I know sometimes when people learn a lot of new things, they can be a little bit like, wow, that's a lot. But let's learn that, because when we are starting from the other end, that's called the omega end, not the carboxylic. So other end. So omega-3 fatty acid is simply omega position, you start, and then 1, 2, 3, which is the first double bond at 3. If the first double bond is at 3, you call it omega-3 fatty acid. That's it. Okay. So this particular example shows to you here polyunsaturated acid, which is the PUFA. You know, sometimes, you know, those oil bottles have labels on them, PUFA. And it has the third position of carbon is a double bond. So it just depends on how people are naming it. But I hope, let's now look on the right side. 20 is for carbon, 5 is for double bonds. This is for location of double bonds. These are methyl carbon positions. So methyl carbon meaning on the other side. So this should give you a complete picture of what a lipid would look like. Okay. So number of double bonds. Yes. So here is the steps that are given to you. However, if you have anything that's getting a little bit, you know, difficult, or anything that's can be explained again, I'm happy to do that for you. Also, we will have more chances to talk about this. Now, you might have heard of trans fatty acid and how trans fat is bad. You know, those French fries, you know, they say, oh, they have trans fat. That's bad for you. That's bad for your heart. Like, why do they say that? Okay, let's see that. Let's figure out that mystery right away. So a cis means that your double bond is going to have H on the same side, which means that it's going to have a kink. However, a trans would mean that the H is on the opposite side, so it looks like straight. That is dangerous. This to me looks like a saturated fatty acid. This looks to me straight. So what happens is, this looks to me like, let me see if I was to draw this. This looks to me like it's going to pack like that. You know, so even though it may be some kind of oil or whatever, it's going to behave like a saturated fat. Whereas this, on the other hand, is going to be like this and like that. And so it's going to be a liquid essentially. And this essentially, there's no bending, as a result of which it is a way more compact structure. So cis and trans, same concept. So you should be happy in a way that you're relearning cis and trans, but this should remind you also of trans fats, which people say, oh, those are real bad for health, right? And so what happens here is a chart which shows to you what is saturated fatty acid, what is trans, what is monounsaturated, and what is polyunsaturated. So all of these are shown here. These tend to remain solid, and you know, what are the things which have trans fat? All the things that we really like, fast foods, processed snacks, they are full of trans fat. And the things we are, you know, which are really, really healthy, the plant-based foods and oils and fish and certain vegetables, they are all the good fat. Okay, so that's the impact on the health. You know, this raises the cholesterol, increases the risk of heart diseases, and keeps the intake low. So that's why, eat French fries, but remember they do have trans fat. Whereas if you are eating something like an avocado, you're making that right choice, it lowers the cholesterol, it may reduce risk of heart disease. At least it does not increase the cholesterol. Let me just say it in a different way here. At least it's not like it doesn't act as a medication, but it doesn't really increase the total cholesterol. Okay. So you can see some of this chart. It's just saying the same thing, that there are low density lipoprotein, and in a normal cell, it's it's converted to like low density lipoprotein carries dietary fats into the cell, and what HDL does, it carries impurities out of your cell, which is kind of nice. Okay. So in a healthy cell, when you are eating unsaturated fats, then you are raising the HDL and it lowers the cholesterol. So once you're eating a lot of, the healthy or the cis unsaturated fat. However, if you're doing the other way, if you're eating saturated fats or trans fats, then less HDL, which means that there is more blockage. And that blockage can actually lead to, the restriction in blood flow. So that's the definitions are right here. So, it does take a little bit of time just going through that initial part, but we are going to do a little more. So just letting you know, we have still a couple, about 20, 25 minutes at least left here. So there is omega-6 and omega-3 fatty acids. And if you see here, these are they are essential fatty acids. They are not made by that you have to intake them. Okay. And if you do not have, if a person doesn't have sufficient of amount as needed by the body, then it can result in impairment of brain development. So leave some of the easier stuff in here, in the sense like, okay, you can read the details of how it works. I also would suggest, like, hey, if you understood some things, you can just write the discussion for module 3 and be done, so that kind of take that away from and focus on your exam a little bit better. So saturated fatty acids are the examples are shown here. You can see the common thing is that all have no double bond. So that's why 40, 60, 80, the zeros indicate zero double bond. Whereas unsaturated, you can see they have varying number of double bonds at the locations. So the positions of double bonds are shown here. And these are some of the examples. Yeah, like I wouldn't ask you trick questions like how many carbon does arachidic acid or behenic acid have? I wouldn't ask you such questions. That's why I said nomenclature is not of extreme importance while we are doing this in your particular course context, though, even though it is important. So what can it cause? You can read through this. It's just, I'm going to skip the slides which are easier, which is something you can do, and come to something which is more, I guess, material wise, we want to make sure we cover everything. So triacyl glycerol is nothing but 3 fatty acids that are linked by an ester bond. You know what is an ester? It looks like acid, but not really an acid. It's like a, it has a COO bond, and you can see 3 of those, and linked to a glycerol molecule, which is actually looking like this. So you can see how it would work, and a water molecule would go away and would form that. So there's a triacyl. So acyl is for these. So 3 of these, triacyl and then glycerol molecule. And that's what it is. So triacyl triglycerides are esters of glycerol and fatty acid. Just another name, just saying the same thing. So they can be simple. Everything is the same. They can be mixed. Chains are different. We kind of know what the lipids are for, but they're used as energy source, as in waterproofing, so that they can form a waxy layer, insulation, protection, all of these. So this is an interesting slide. I got it from one of the research papers, where I saw that they had these fats labeled the lean fat, cells, the adipocytes were from an individual who is lean versus obese. And you can see that they have different amounts of, those cells look very different in different samples. So this is taken from, actually, these are mice samples. So triglycerides or triacylglycerol, they can be oils, fats, they are non-polar and hydrophobic. And just as a comparison, because we were doing carbohydrates so far, carbohydrates and lipids are a little bit different because of the kind of energy they store, short-term versus long-term, effect on different things like osmotic pressure. This is with reference to the plants. So carbohydrates are more impact and this doesn't have so much. How readily are they digested? Which one stores more energy? You can clearly see fat is a big time winner here because a lot more energy can be produced from fat. These are water soluble, these are not. So these are different things. Triglycerides can undergo reaction, which is different types of reaction. One of them is saponification, there is hydrolysis and hydrogenation. So now you kind of see the pattern. We talk about a molecule, we talk about how to name it, and then we talk about what the reactions are, so pertaining to the biochemistry part. So hydrolysis, or breaking something with water, so that is there is a H2O molecule, just like we did in carbohydrates. You break it up and you are separating the fatty acid chains and the glycerol. Whereas hydrogenation, again, extremely important, and this is all like leading to your exam too, is getting rid of those double bonds and replacing them with hydrogens. So, so it is something that is possible only in unsaturated fats. Saturated fats already have all their H and they never have any double bonds. So it's hydrogenation is only possible for, like I said, unsaturated ones. And finally, saponification. So in which there is a fatty acid and it reacts with a base and it forms, salt of fatty acid, right? So if you see here, there is the glycerol is separated and it is, I'm not saying it's replaced, but it's the acid part with the base, and that forms the acid and base. When they come together, that's a salt, right? So that forms the soap. And then interesting fact is all the hard soaps that you use come from sodium hydroxide, and all the soft soaps that you use, such as any kind of liquid soaps or shaving creams, they are all potassium hydroxide. Okay? So those are some of the things that are kind of, again, the correlation with what we eat, what we do, and that's what brings it together, right? So with this, we are almost done with this part, and we are going to move to a different kind of lipid. So if you remember, so far we've been talking about, more like triacylglycerol or waxes. Waxes are also esters of fatty acid, and they have much longer chains, like 14 to 30 carbon atoms, as opposed to those having more like 18 or 20, right? So the coating of wax helps the plants because it prevents the loss of water. And you probably already know that plants that survive in conditions with low humidity and more drier regions, they really, really need that wax coating so that the loss is prevented. And so this is an example of, or actually the schematic of how a wax would look like. It's an ester bond, again with an alcohol and fatty acid. This remains the same, but in the sense it remains the same in the sense there is fatty acid, there is alcohol and an ester bond. That's like kind of a lot of lipids going to be looking like that. Just the type of fatty acid or the type of alcohol will change. So these are some of the examples of waxes you might have heard, like beeswax or some other examples, which you can see for yourself. Okay, so with this, we come to the structural lipids. The structural lipids they form the structural part of biological membranes of cells in all kinds of living organisms. And if you see here, we have a little bit of a chart to remember. So I want to continue, but I do want to give like a 1-minute break to see if people have any questions. So I'm going to stop sharing. Was this tiring so far, guys? Do you have any questions? Anyone has any questions? No one has any questions. You guys are probably tired. Okay. I'm going to go. Let's see. Was this a lot of information?
Yes.
Yeah, I know, I know this was a lot of information, but I always feel when we have to tackle with a lot of information, let's do it in the front end rather than later. So that, and that's why I said, once we are done, I would like go back, and if I would be you, I would just go back and complete the discussion. So that I don't have to take care of that part, and I'm done with it. And the no quizzes are to be answered. So just focus on the exam then. Okay, so when we do this, what's going to happen is, I already know this is going to be a little bit confusing. Okay, not that I'm trying to say that, but it is always so. Please be assured that next time when we talk about this, I will come around this part and maybe start from this part again. Okay, because when you see all these different ones, they do look like a lot to remember, but there is a little bit trick. So if we do it 2-3 times, then it won't be so daunting. Like it would get better. So thank you for holding on and all your patience, and we are just going to get through this real quick. Okay. So let's see. So what I did was I made like a nice layout for every type of lipid. So it'll help you keep everything in one place. So cell membrane lipids, because now we are talking of structure. So structural part, we are going to talk about phospholipids, glycolipids, and cholesterol. Okay. So in this one, when we talk about lipids and we talk about these three things, we are going to think first of all about, we're going to start with phospholipids. So phospholipids, if you see here, they have a phosphate group. They have, the glycolipids, they have a glycol group, which can also be called a sugar group. So if it's phosphate groups, phospholipid. If it doesn't have phosphate, sugar group. Okay. So again, there is a phospholipids contain an ester link between a phosphoric acid and an alcohol. So again, there is always acid and alcohol. There is always an ester link. But in phospholipids, it's between the phosphoric acid and alcohol. Whereas in glycolipids, things are a little bit different. You're using a fatty acid, but you're combining it with another type of alcohol called sphingosine. That's why it's called sphingo. It has a different name. Okay. So phospholipids, again, it's easy to remember. You have a phosphate group, it's a phospholipid, and it's an ester, but it's phosphoric acid with the glycerol or sphingosine, right? If it doesn't have any phosphorus, then it is the glycolipid. So if you see here, we are just trying to expand on these little figures that we saw on the last slide, right? And see here, this is the phosphate group, okay? And that's how it forms the, the fatty acids are not really kind of shown here, that forms a bond with the glycerol. And these are the ester links with 2 other fatty acids. So there's green fatty acids are on the bottom actually and forming the ester link. And this one is forming with the phosphoric acid. Same thing here. What is the difference? The difference is this, there is no glycerol. This is a sphingosine. Okay. And so this is called a sphingomyelin. Again, I'm not going to try to ask you trick questions in this. For example, I wouldn't give you the structure in the exam or assignment and say, identify this. That's too much to ask for. Can I ask you if it's a phospholipid or not? Yes. I think that would be a question that I would ask you. Is it a, let us say I could ask you, is it a lipid or a carbohydrate? So Will you be able to identify that? In a lipid, I can ask you, is it a phospholipid or a glycolipid? So those kind of questions are more like identification and majorly categorizing them basically. And then this is your glycolipid, and it has this sugar group or glycol group, and that is what is combined with the sphingosine. So like I said, I made this really nice layout for you where I have the definitions, the types, and the use in human. Okay. So phosphoglycerides, also called glycerophospholipids, both are the same names. Okay, they are membrane lipids in which two fatty acids are attached, and there is an ester linkage. And this is how it looks in the human. So we are not going to do this in detail because we have only 15 minutes left, but we are going to go over them so that we'll have a little bit of outline in our mind. Okay. Sphingomyelins, since we know the basic, I guess the basic idea for this, we do know that it is going to contain a phosphate group because it's still a phospholipid, but it is attached to an alcohol which has a nitrogen in it. And that's what makes it different from phosphoglycerides or glycerol phospholipids. Okay, what are the uses in human? Very, very important use. The use is that it is the main component of myelin sheath of nerve cells. So without this, if there is no proper myelin sheath, then you can imagine there will be a loss of signal, and it can lead to a loss of function and a loss of the body to do its function, movements, I don't know, anything can be affected based on what it is. Glycolipids, carbohydrates attached to the fatty acids and alcohol. Okay, so those are the glycolipid examples. And what are they used for? They have a very important role in identifying different blood types, because in different blood types in RBCs, different types of glycolipids are attached. So it helps distinguishing a blood group A from B, and so on and so forth. So far we did these three, right? This is what we were looking so far. And the next one is steroid. The reason I love steroid, very easy to identify. They are fused ring structures. They're kind of merged with each other. And they are usually, these are mostly hexanes. So if you see, they have 6 sides, right? And all of these points, reminding you that these are all carbons. So they are designated A, B, C, D. And I'm just showing to you in different colors so that it's easy to identify that there are 4 rings. And they can be different based on what the R group is. So let us see. If it is R group is H, cholesterol. If it is C2H5, cetosterol. If it is this, it is. So you can see all these functionality of steroid will change based on the R group, and R group simply is typically always the carbon hydrogen. Basically, it's a carbon chain, and you just make sure all the hydrogens are there as needed. So cholesterol, estradiol, testosterone, cholecalciferol, all of these, or vitamin D, all of these are really important structural lipids, and they are found embedded in the cell membrane. And many of the hormones, such as estradiol, testosterone, and vitamin D, they are derived from alcohols, and they are also, steroid alcohols, also called sterols, especially cholesterol. So that's why the name sterol. Okay. So you can see that they are embedded in the structure in here. You can see cholesterol is one place is here. You can see that there is phospholipids. You can see there is glycolipids. This figure brings together all the structural lipids we talked about. We talked about 3 different things, and it brings it all together. This model is called the fluid mosaic model, and you might have learned about it. Okay, so there are some properties shared here, which you can kind of go through it, how passive transportation happens for molecules down the gradient, then from more to less, and active is against the gradient. Okay, so those are 2 things, and these are the easier part, which you can kind of read and understand. Now comes the signal part. So that's kind of almost the last part. We're almost getting done. So there is a bunch of lipids, which kind of really, they don't really look like the other lipids that we discussed so far. They're different. And they are, some of them are really important in terms of hormones. Okay. So what do they do? So for example, they can be vitamins. Vitamin D, A, E, K, all of these are fat soluble compounds, and they are essentially, they are very different. You can say A and E and D and K, they are all quite different in their functionality as well as in their structure. And you can read about the function from here. You probably have some idea in the sense that, vitamin A is essential for vision, vitamin D is essential for calcium metabolism, vitamin K is a great blood clotting factor, or it's important for that process, and vitamin E is an antioxidant. So you can read more about these. Lipids can also be used or important, in mitochondrial functions and pigments. So there are other kinds of lipids. If you see here, they can be doing some of those important roles. For example, there are ubiquinons and plastoquinons, which are electron carriers in mitochondria and chloroplast. Then there are other lipids which can serve as pigments in flowers and fruits and give birds their color. So that's why I showed you some examples in here. There is xanthine, which gives the bright red color, and zeaxanthin, which gives the bright yellow color. So these are some, this gives some functionality, as well as, you can see the structure here, similar and yet not exactly identical. You can see here the ketone group and the hydroxy group. Actually, that's about it. Let me stop sharing. Like I said, I'll try to get it done by 3:45. Time is 3:50 right now. Thank you so much for your patience. I will make sure this recording is available within the next 1 hour. It takes about an hour to upload in the YouTube. But if you have any questions, you can ask me now. So nothing for exam 3 is in the module. I'm sorry, nothing from module 3 is in your exam 1. So you can be assured of that. But, for me, I think it's very important that everything that we do, you are doing ahead of time. If we are scrambling and doing this 2 weeks later, I don't think that will be a good idea. So that's why we did it. So only module 1 and module 2 are in your exam 1. Okay. There is nothing from module 3. You don't need to worry about it. That's why I said only discussion 3 is due this week. Please go and just fill out that discussion and say, I learned about this thing, and complete at least 3-4 things, and then you will be.
Sorry, Professor, can I ask you a question? Can I just
Yes.
confirm? I did the poll. I just want to double check. My appointment is on Thursday at, the 19th at 12:45 to 1. Can I just double check real quick?
Yeah, I think I have the doodle poll out.
Because
So
I'm not sure if it went through, so otherwise I just pick another day.
did you say 1:45?
12:45 to 1.
All the appointments are between 3 to 5 kind of thing, or 4 to 5.
Oh, no, on the poll was one that was 12:45 to 1. That's the one I picked.
Oh, okay. Then I think that might have been
Yeah.
cancelled, because there was 1 or 2 mistakes that did happen, in the sense like someone signed twice and 1 or 2 people, and 1 or 2 were my mistakes. That one timing was incorrectly just the doodle poll is very sensitive. You put the mouse and it's like ready to click and be out there for you. Like, I don't know.
I just want to double check so that way I know the date exactly, because I'm not sure if it went through or not.
Yeah, what I'll do is I'll stop recording for now so that our session is recorded, and I will get back to you. I'm just noting down who all I need to get back to for different things. So I'm going to get back to you on this one.